Okay, thank you very much. Sascha.
Okay, thank you. Okay, so I'm Sascha, I'm from Hamburg. I'm a QA team lead at a company called EOS. EOS is a financial service provider within the Otto Group. Maybe someone heard of the Otto Group. Yeah, I'm here to tell you the story. I was at the CukenFest last year, as you can see on the picture. This is me hosting an open space session on Friday. And yeah, I talked to many people, and there were two things I remembered when people were discussing it. I had in my head, wow, we don't have this problem, and I don't have a solution for that. These two things they were discussing was how to organize a big bunch of feature files and steps. How can we handle the massive of our steps? And the other problem was long-running nightly test runs. How can we make them stable, and what do we do if the night is not long enough, and stuff like this. Yeah, well, why do I think that we don't have this problem? We don't need to solve this. Well, it's not because we don't test. I think it's because of our microservice environment we use. So actually we have 60 people on our project. It's 5 cross-functional teams with up to 10 people working on it. So we have a lot to test, I think. And we don't have any manual regression tests, so everything is automated. But we don't have the two problems I mentioned first. So let's start with a quick view on what is a microservice. So let's take a look at the most common source of knowledge on the internet, Wikipedia. So microservices are a software development technique, a variation of the service-oriented architecture, and they are a collection of loosely coupled services. Okay, loosely coupled. Microservice architecture services are fine-grained and the protocols are lightweight. The benefit of decomposing an application into different smaller services is that it provides modularity. This makes the application easier to understand, develop, test, and become more resilient to architecture erosion. It parallelized development by enabling small autonomous teams to develop, deploy, and scale their respective service independently. So there are a lot of interesting words in it. Let's start with independent. So this means if you are working in a project with several microservices and you change your service, you want to be able to deploy your service to production no matter what the other teams are doing at the moment. This is quite interesting when you think about tests on an integrated environment. So if someone broke something, your tests are red, and you can't deploy your service. That's not independently. So this is something that can be quite challenging. Another thing is small. There are a lot of discussions about what is small in a microservice. I just want to make it short, and here we decided to take the bigger microservices. We use self-contained systems. I think some people would say that aren't really microservices anymore, but I would disagree. What is a self-contained system? So this could be our application. You see we have several services, and each service has its own database, and if needed, its own front end. So this is what it made a self-contained system. It has everything it needs together in one project. These services are only talking to each other with asynchronous messaging. In our case, we use Kafka. This is a preferred messaging when you use microservices because you don't have to wait for the answer of another service. Sometimes you need REST codes. I pointed that out here. The problem with REST codes is you ask another system for something in its database, and if it's don't answer, you wait for the answer. So you're blocked until you get an answer. So if you have, in this case, in our case, we have more than 40 of these services, and if they all depend on each other with several REST codes and waiting for each other, you may be stuck in just waiting forever. So asynchronous messaging is the preferred communication between the services. And yeah, so if you want to deploy and test one of these servers independently, you see you need some technical tricks to do this. The first thing is each service has its own business domain where it belongs to and where it shows its services. So you can find tests from a business view for each of these services, which is quite good. So you have something you can test. And now the question is, how do you do it with the technique? Okay, so we need one of the services in an isolated environment. Now the service is completely alone, all the other services are gone. There's a message bus, and nobody is talking to the service. That's good. So what can we do now? We want to test. For testing, we need Cucumber. So we can now talk via REST with our service. We can trigger tests. We can use some services provided by the service and check if it's correctly. And we can also use Selenium and trigger some stuff with the UI and do some testing here. And we can also send messages to our service. So we can send a message and see, is the service getting the message? Is it reacting correctly? And yeah, is it doing what we want to do? Maybe we trigger some action with the UI and the service will create a message. We can read this message and check if it's a message I would have expected. But now we have some little problems. Maybe the service wants to talk to another service because they are not completely independent. Maybe the service is for writing invoices. So we trigger, please send an invoice to some client. Now this service would ask the client data service for the address. In this case, we don't have an address. Good. If it's a Kafka message, it's no problem. We can provide the correct message. Test is running. But what is, in case it's a REST call, we need something more here. We use wiremock. Wiremock is a mock for REST calls. So all calls from the service 2 to other services are redirected to the wiremock, and the wiremock is mocking the other systems and behaving the way you told it. So in this case, this wiremock would answer with an address. And so the test can be executed. What's quite nice is we can also configure the wiremock via Cucumber in a running test. So maybe we have one test, write an invoice, successful. And on the other hand, maybe we have a test, please write an invoice, but we don't have an address of this client. So we can tell the wiremock, hey, if you ask for an address, say, I don't have an address. And it's just the configuration of the wiremock in an integrated environment. And then if you would have a monolith, you would need the address actually in the database. You need an entry in the database with an address or with some broken address so that the service would answer with, I don't know, I don't have an address. So we can do this just with configuring the wiremock. So we really need less test data and we have less problems with test data creation, which is normally really pain in the ass. So this is a way to test one service. So if you go back to the picture I showed in the beginning, we have all these little Cucumber step files or definitions within our services. So this is why we don't have one big bunch of steps, because it's all distributed between the services. Each test belongs to a service, and it should not be too many tests in it, because if there are a big bunch of tests, the service is too big. So this could be the point where you decide to split the service into two services, because it has a lot of business logic in it, and it's not so micro anymore. So this is how we avoid the problem with the big step files, step definition. The other thing is we don't need to run all these tests all the time. If we just change something in service 3, we just run these tests, which are in service 3. We don't need to run these tests and these tests. So we only need to run the tests that are really needed for the change we made. And you can, in a monolith, you can use some tools to do some test impact analysis so that they only run the test where the change was. I have no idea how good this works, but I think this is much easier and it's safer because it's, yeah, there's no logic behind it. But on the other hand, we still need to test if all these services together are really still a working system. So it's each service is working on its own, okay, you know it, but the whole thing needs to be still one running system. So we still have some test on top of it. This is an own repository for tests on the integrated system. So we use this, we have some tests which are more long-running workflows we use. So this is a critical business path we test in this at this stage to make sure that everything is not broken at this moment. Just to give you some numbers of that, we have 43 apps at the moment, or 43 services, and we have about 1,500 scenarios in all the services together. And the longest test run for one app is about 20 minutes. And we have 13 tests on the integrated level. So, and they need about 15 minutes to run. So this means for the biggest service, we have a test run of about half an hour. So in total, it's from check-in to deploy to production, we are 1 hour, maybe. Yeah, we can put a change to production within 1 hour with this set of tests. And as I mentioned before, we have no manual regression testing, and still it's fast, and yeah, you don't have to deal with big bunches of tests in one environment. And yeah, that's what I wanted to tell you. And I see I have 2 minutes left for some questions.
This is brilliant. I think this is probably the number 2 or 3 question I get asked every time I go and do a training course somewhere about how to make BDD happen is these questions about microservices. I'll put the microphone closer, is that better? Yes. Yeah, so great talk, great answers. Really common problem. The question I've got is about documentation. So we talk a lot about feature files being documentation that will make sense to a business stakeholder. Now, your documentation is kind of fragmented by being placed with each of these services. How is that working in terms of the connection that you're able to maintain with those business stakeholders for you as a team?
Okay, let's go back to this picture. So, as I said, each service is responsible for one business area. And so we got 5 development teams, and each service is connected to one team. So the teams also have their product owner within them. So what we basically have is that we have only business processes which are only covered by one service. So they are not really distributed. The only distributed business flows we have are on this workflow level here on top. And yeah, that's more long-running, bigger tests, but not so many.
So what it sounds like what you're saying is that the architecture that the way the responsibility is distributed to the services is aligned with the way that the domain is, the problem domain is shaped.
Yeah, correct. Thank you.
More questions?
Do you use Cucumber for your production synthetic monitoring, if you have any, and do you use it for contract testing, or is that possible?
For contract testing?
Yeah, like CDC type tests, consumer-driven contracts, or even the live synthetic tests. Do you use Cucumber type tests to drive those production? As in, can you run those in production? Those tests?
No, we can't run these tests in production because they're changing data and stuff like that. So this is not possible. Consumer-driven testing, yes, we are using Pact for the communication between the services. I skipped it here because it's 50 minutes.
Thank you.
Did you try to run Cucumber in the same process as the microservice without any networking, just direct method calls, in order to speed up the tests?
No, at the moment the tests are executed on the build server and the environment is running on another system, so we have the network.
Right, but did you consider trying to run them in the same process or is there anything stopping you from doing that?
I think nobody figured out how to do it in our company. If it's possible, we will try it.
Open space tomorrow.
I'm going to say thank you very much, Sascha. Really interesting talk.